Hey, what's up everyone? Welcome back to Tease Time. I'm TJ. Today we have one of those teachable slash coachable moments. Yesterday I was in the process of getting my cabinet stuff situated and decided to turn on the air conditioner. As you can see, I started to take stuff apart to diagnose why it wasn't working. The fan kicks on. It appears that the AC compressor is not kicking in, or it kicks in momentarily, then it shuts out, which makes me believe it's a capacitor. So I started with the easy stuff on the inside, checked for any loose connectors. I was trying to put off going on the roof because the solar panels are kind of in the way to take the cover off to access like the side panels for like the capacitors and stuff, like when I did the easy start. Yeah, and why I believe it's a capacitor, because like it attempts to kick on, so it's either like if there's a relay in there, it's either relay or capacitor. So I believe it's like one of those, or hopefully it's just a loose connection, just from road vibration. I'm hoping it's a loose connection. So I'm gonna go climb on the roof, and also this is what a capacitor looks like on the AC unit. It's a Coleman. It's a Mach 3. But like I removed this one when I installed the Easy Start, the Micro Air Easy Start, just to kind of help for amp draw, like when the compressor stuff does kick on. So this is like an old capacitor. I'm not sure, depending on what is it, the microfarad rating of the capacitor. If I find there's a faulty one, I might be able to throw this in temporarily until like I get new stuff situated. But kind of getting ahead of myself, saying to replace something which I don't know if I need to replace. But yeah, I got the fan shroud off. I already checked inside for loose wiring and everything. Like the fan kicks in, the thermostat is working. Everything right here is good. Like I turn it on, the fan operates, so we do have fans. So there's a fan capacitor that's working, because like that changes like pitch and everything. And I'm basing all this off of just my color controller over there, because it measures the watts. So like when this usually kicks on, it's over like 1,000 watts for the air conditioner, for the compressor to kick in. So it's doing that momentarily, but then it'll cut out, and then it won't do that, but the fan will still keep blowing. So like it's attempting to start. So I believe there's like a start and a run capacitor. But enough yapping. I'm gonna get to the roof. I'm trying to do this like quick. It's earlier in the day. It's supposed to be a high of, I think, like 88 today. Yesterday it was pretty warm. It was like in the 80s also. That's why I tried to turn the AC on, and I was just like, you know what? I'll save it for another day. So that day is today. So let me get situated. I need to get on the roof, and hopefully I can gain access without too much of a struggle. Like I will have to probably climb under like the solar panels to get to it. But yeah, let's go. Oh, and before I get ahead of myself, let me actually show you what's going on. As you can see, it's off right now. So this is Max Cool. Come over here, and if you can see, like the watts jumps up. See, that would be like normal operation, and building, getting up to over 1,000 watts. And there it goes. So that's the problem. The compressor's not staying clamped and holding, so we'll turn that off. And then also you will hear like a whine from the multi-plus. Like it sounds like a relay's kind of like somewhat grabbing, but not completely grabbing. But that's how I'm determining like the compressor's not like holding or clamping. Like the fan blows, so like you may think like, oh, the AC's on, it's not working. But based off of the wattage, the compressor's not clamping. So roof time. And before you do any electrical, make sure you disconnect all your power. If you have a breaker, come over to the breaker, make sure that it's off. So that's off. Don't get electrocuted. Safety first. If you really want it to be like on the safe side, you could shut down like your inverter if you're doing like an off-grid or whatever, just so there's no chance. But that's off. We have the off on the AC unit itself. We're gonna get to the roof. I'm gonna show you how to test like the capacitors and stuff with a multimeter. This right here, just getting all my stuff together, all the tools and stuff I'll need. Yes. Okay, cool. Yeah, so got this. Gotta take the cover off, gain access to the side panel. Gonna need a screwdriver. Yeah, screwdriver, multimeter, a screwdriver, isolated screwdriver to discharge the capacitors. And yeah, we're getting there. And make sure to discharge by connecting the terminals together. Alright, so I have my little workbench set up right here of things I'll need to test. So 1 UF stands for microfarad, MF is a millifarad. 1 millifarad, 1 MF is equal to 1,000 UFs, microfarads. So I'm gonna just use UF and MF going forward. Mainly it's gonna be UF. MF is this. That was replaced by the the what is it, the little easy start that I've installed. That replaced that, but like I could temporarily install that. This is temporarily just a test. Do not keep this in there, because this is rated for what is it, 88 to 108 MF. So remember, 1 MF is equal to 1000 UF, and these are rated. This is 7.5, and this is 35 UF. So just keep that in mind. So what we need to test today are these two right here. So I'm using a multimeter. I don't have like the function on here to do it in capacitance or capacitor, where it'll give you a exact number, the 7.5 or the 35, but you can still use this as in ohms, and then just check for the resistance. For right now, it's an infinity. So once you do these, disconnect the power, make sure that they are discharged by connecting the two terminals. Make sure you use like an isolated, like a screwdriver, just to make sure you get all the juice out of it for both of those. So those are good. Yes, I did that on the top as well before I removed them. But yeah, so right now we just connect our leads, and then what you should see on this, it should start from a low to a high to reach to the point where it's in infinity. So it might take a little bit, but if it just stays low, it doesn't move at all, it's bad. So let's see. Actually free up a hand. Let's see. You can see this. So boom. And also to check to see if each terminal is grounded out to the bottom, to the body of this, you could set it to continuity. So if it shorts out, it makes that buzzing noise. I like using that. So you connect each terminal like so. Touch the body, no noise. Touch the body, no noise. So it's not shorted there, but just by how that was moving, how it was so all over the place, this is bad. So let's check the next one, and let's see if this one is bad. And like I said, double check, make sure you discharged all the power by connecting the terminals like so. And then put this back. Okay, so I retested. The one that I originally said was bad, it is not bad. It is fine. My connector on the probe was loose. So this is fine. This is going to infinite. As you saw, the numbers slowly build up. So that one is good. This one did absolutely nothing. So this one right here is the bad one, the culprit, the reason why the capacitor isn't clamping. So I'm going to order another one. Or actually, I'm going to order two new ones because they're from like the same year. So like if this one went, that one's probably not too far behind it, especially since it's a pain to get to the AC unit crawling under the solar panels. It's a little toasty under there and just crawling. So I'm gonna go ahead, I'm just gonna order both of those, and then when they come in I'm gonna reinstall, and then we're gonna finish this video. But for right now, I'm just gonna order those parts. So this is to be continued in this video. But like that's a good way to test. Like if you have a multimeter that doesn't show capacitance, where like it'll give you the actual number, you wanted to see that number slowly climb till it reaches infinity, which is it turns to 1. So yeah, so yes, so to be continued. Order parts. We're gonna see if that fixes the problem. It should fix the problem. Hopefully it fixes the problem. It shouldn't be hopeful, like it just showed. This one is the bad one. So if anything, I do need to replace this, or if I wanted to, I could go up top and throw this in its place just to test to see if it comes on. But like I have time, like it's fine. We'll make it happen. I'm just gonna order what I need, the right stuff. So to be continued. All right, and we're back. I have new capacitors. This is what we have here. Bojack Ken. Let's call it that. Bojack Ken. So we have different capacitor. They're the same ratings, but the sizes are the only thing that's different from them. So just mounting them in there, I just probably have to adjust a little bit. But right now I'm just going to show you the two that I have. This is the difference in the size of them side by side. You see height and thickness wise. Just new one's a little shorter on this one, but it's just a little thicker, as you can see. And I'm going to retest these just so you can see. I'll show you which ones are working. 3 are good. 3 out of the 4 are good. So one of the old ones is good. One of the old ones is bad. The reason why we're replacing it so we can get that capacitor to lock up. And these should be new. There should be, they should be good. So what we're going to do, we're going to just make sure we get all the charge out of them. Even though they're new, we're just going to go ahead and double check. Make sure. Isolated screwdriver. Yes, yes, yes. Cool. And as I said before, I'm testing in ohms. Yeah, it should go to infinity. The number should slowly raise. The number should slowly raise if it's good to infinity. Slowly or fast, it should rise. It should have some movement. Previously, when we were testing the old one, the bad one wasn't moving at all. So that one was bad. So right now, we're going to connect these, get stuff tested, try to get a good angle. You can pick that up. Good shot. So you get numbers and the capacitors all in the one shot. Let's go side by side, and then we'll throw the larger ones in the back, like so. All right, so for the first one, try not to block those numbers. And as you see on the meter, it should slowly raise as it is. So that one is good. Let's go to the next one. And good. Check these back ones. And give it time to do its thing. and good. And this one is the bad one that we previously tested, just to reconnect, just to confirm that. And as you can see, there's no movement on that, so that's the culprit. And we're going to replace that. We don't need to replace this one right here. I'm just replacing them all for the simple fact it's not the easiest for me to get to, because I have the solar panels to worry about. If you don't have solar panels, it's not that bad. It should be pretty easy and simple for you to get to. But for the simple fact that I have to crawl into the panels to get to these capacitors, I'm going to replace them all now. Yeah, so we tested. Those are good. So I'm going to go up top right now and reinstall those. And as you saw me take them out, it's the reverse of that. And make sure hopefully that you had took pictures before you disconnected the old capacitor, so you see where all the wires are supposed to go. Put them back in their corresponding locations, and you should be good. So the next time you'll see me is turning on the AC to test to make sure that it's actually locking up. And I'm going to test that by seeing what like the wattage is on the color controller, so we can see where our power is coming from, because that's a good indicator right there. It tells me like if it's locking up, because I know it should be at. But right now I'm gonna go to top, gonna install, get that situated, and I'm not gonna like zip tie everything up until I actually test it, and then I'll go back up after the video's closed out and everything, and get everything like put back together, zip tied, all that stuff. So hold tight. I'm gonna go put this back in, and we shall continue. All right, so round 3, I replaced the capacitors. The capacitors weren't getting the clamp. So right now we're at 978, and it's rising. 98, 976 watts. Yeah, 969, 968, 971. So I'm gonna watch that and keep an eye on it. What I did, I have that easy start in there. So I kind of took that out of the loop and like kind of reinstalled, or I did like rewire it like how it was like originally. I jumped in the old start capacitor, because the easy start is using it is the start capacitor now. So I took that out the loop just to kind of see if that was the issue, because like it wasn't clamping. So like I checked the wires, all the wires seemed good. Everything seemed to be, everything was wired how it should be. So there's like no reason why it shouldn't be at where it's at right now. So I do have my temperature gauge up there measuring. It was at 80 degrees, it's dropping down. So it's at 60 right now. I'm at a high cool at the lowest setting. So it seems like I might have to take out that easy start, but we're doing like the process of elimination. We did test the capacitors. The other capacitor was bad, and you usually have to kind of think of like, why did the capacitor go bad? And most likely it's something with the easy start, so I'm gonna have to take that off to diagnose and test that to see if like that's actually bad, because if so, that's coming out. But luckily, like I can wire in, as you can see, like the watts are climbing. So that's normal, what it looks like when the AC, the compressor is clamping. So the easy start needs to come out, and I can at least I can rewire like the original stuff in there, just so I can have something so it's still running. So I think there's one wire that's keeping the easy start in right now. It's a black wire. I just to cut that and cap that stuff off, and we should have AC until I can figure out what's up with the easy start. The temperature is still dropping. If it touches 40, 40 is about where you want like max cool to be. If it reaches 40, it kind of tells you like it's topped off refrigerant wise. Should be good. But yeah, usually when things break, there's a reason. Like capacitors, they usually go bad anyway. Like those are from 2010, so it's 2022, so they actually probably lasted longer like than the recommended suggested change interval. So that's cool. So at least I know I have AC for now. But I'm gonna go up top and just cap stuff off to make sure like nothing browns out, all the wiring and stuff doesn't cause any more issues. But I'm just pleased that I got it to go. So on the diagram, like I'll try to put a picture of the diagram in the video. Don't hold me to that, I'm gonna try. If I do, it's right now. Of how it was wired before, and the only difference is the easy start and the start capacitor that originally came with it. The easy start is kind of supposed to lessen the load on your electrical system when it starts it up. So things go bad, so it might have went bad. Looking like it did go bad, because like now my AC is running. So yeah, so I need to pull that out to test it, but at least I have AC until like I can figure out like what's up with it. But yeah, so till next Wednesday, I'm gonna close this now. This video might continue. So till next Wednesday, perseverance pays off. Trial and error, it's part of life. We'll figure it out. Peace, DJ.